I actually did send the email to organizers half an hour ago asking for a different person when I saw who was going to introduce me. So that was unfortunate, but you cannot have it all. Anyways, my name is Viktor. I would like you to ask me questions at the very end because this is the face I'm going to make. I'm warning you in advance. I work with Upbound, I have a Twitter account, I belong to some groups, doesn't matter. And this doesn't matter either. Okay, this matters. So, Kubernetes admission, I'm guessing that by now everybody, who is not using Kubernetes here? Anybody? Anybody? Okay, you would not admit it in public anyways. So admission controllers have been in Kubernetes for a long, long time. Long time. All right, everybody knows it. Even if you don't know how to create them yourself, you've been seeing them in different tools, whether you know it or not. Admission controllers are probably one of the most important parts of Kubernetes. And what admission controllers are essentially is a webhook that will notify something when something happens. That's the most scientific explanation I can give you. And in an essence, the short version of how it works is that you send a request to Kubernetes API. I would like to have this thingy, whatever that thing is. It goes through RBAC to validate whether you are who you are and whether you can do whatever you're supposed to do, boring stuff. And then it goes through first set of admission controllers. And the first set of admission controllers are mutating admission controllers, meaning that they're changing what you wanted to say into something else. Typical example would be if you service mesh, for example, and you say, I want a deployment with pods that have this container. Service mesh would use a mutating admission controller to add additional container to your pod that will act as a sidecar, right? Or if you want to roll it out yourself, you could create a mutating admission controller that will specify requested amount of memory to 1 gigabyte if nothing was requested, right? You can change, you can define how something changes before that something is applied. I already talked about that. And once mutating admission controllers are applied, a new or modified version of the resource is created, right? Assuming that there are any mutations. After that comes validation of the schema, right? We cannot validate whether something is correct before we mutate, so we change things, and then we validate whether those changed things comply with what Kubernetes understands to be the schema of that resource. If it's okay, and we get to admission controllers or validations, the validating part of admission controllers. And this is actually what I want to talk about today, right? What validations are essentially doing is going through certain processes, or to be more precise, not going through any processes. In Kubernetes itself, there is no validating admission controller. What there is a webhook that if you have a tool, like Caverno, for example, or OPA Gatekeeper and a few others, those tools, those processes will be notified that you want to do something, and then validation processes would run and say, you can do it or you cannot do it, right? This is yes or no type of situation. Now, that was the situation until recently, right? And it still is. But I will get to that later. And if it's okay, then and only then, something is written to etcd. Think of etcd as the database of Kubernetes. And only after it is committed to etcd, you get your resources running, right? Only after all those steps, and quite a few others, something is created in a Kubernetes cluster. Now, what happened, the change that happened, maybe half a year ago, if I'm not mistaken, or something like that, is that apart from Kubernetes being capable of firing notifications, hey, would somebody like to validate this resource? Now that those validations are baked into Kubernetes. Or to be more precise, they're alpha version or beta, I'm not sure the current status. It's still not available out of the box in Kubernetes, but it's coming, right? And what that really means is that you can continue using the tools that you're using today, like Caverna, OPA, Gatekeeper, and so on and so forth. Or you can just say, hey, I'm going to use what is available in Kubernetes out of the box. And I'm going to define my own policies that will decide whether something is okay or something is not okay, right? And this is a simple example of a validating admission policy, right? Just by reading it, you should be able to understand what it does. Hey, I don't have no laser here. Anyways, hey, I want to fail under certain conditions, and the match constraints are saying, hey, if there is a deployment and somebody wants to create it or update it, then you should, I didn't have alcohol yet. That's my body saying you need it, Viktor, so I'm going to be brief. There is alcohol is going to be served after my session. Anyways, so this will fail if somebody tries to create a deployment with more than 5 replicas, right? So up to 5, according to this specification, is okay. Anything above 5 would be a failure, right? Very easy. Anybody can understand this. And anybody should be able to write a validating policy like this. And the second part of that policy is saying, hey, how do we bind this, right? Because policy itself is not doing anything, but then you can say, like in this case, hey, this policy should be applied to all the namespaces that have the label environment set to test, right? You decide, you create a policy and then you bind it to something, to a namespace, to certain types of resources or cluster or something, right? Easy, everybody can do it. I mean, everybody can do it among people who never used Kubernetes. And those who did use Kubernetes will realize very soon how complicated that something is. So, does it work? It doesn't. And the reason why it doesn't work, at least not under the common way people use Kubernetes, to explain that, I need to explain how we work with Kubernetes, right? We, out of the box at least, in Kubernetes, when you just without anything extra, what we're doing is actually, I have a demo here. So let me run a demo and show you what I'm thinking, right? I'm going to copy and paste because all good developers are copying and pasting things. There we go. It looks like I know what I'm doing. And actually all I'm doing is copying and pasting. I did not even write those slides. I don't know what's going on. Something. What does matter is, this is the simplest, one of the simplest possible applications you can have in Kubernetes, right? It's a very, very simple one. I'm not using anything fancy like virtual services or anything like that. And this application has 2 pods, one for the database, another one for the application itself, has 3 services, 1 deployment, 1 replica set, 1 stateful set, 2 config maps, 1 secret, and 1 ingress, right? Now, how hard would it be with only this example to create policies that will ensure that what we're doing, that we're doing the right thing? And this is the simplest possible example, almost the simplest possible example I could think of, right? If I remove the database, then it would be really the simplest possible example. And the problem with all this is that we are creating a bunch of resources. Any serious setup in Kubernetes application or anything else ends up with dozens of resources because Kubernetes, the core Kubernetes, is designed to be very low level, right? There is no such thing as application, right? You cannot create an application in Kubernetes, at least out of the box. What you can do is, hey, it's similar to AWS here in a bit, right? You cannot, in AWS, you cannot create EKS cluster. No, you need to create EKS cluster and 1 or more node groups and infinite number of subnets and VPCs and internet gateways and so on and so forth, right? And that's great because being very low level means that we have a lot of flexibility. We are in control. But then when policies are concerned, we need to take account of all the possible resources that we can manage in Kubernetes cluster, number 1. And number 2, all the permutations between all the combinations of those resources. Sounds confusing, I will show you an example soon, right? First I'm going to delete this because I don't need it anymore. Anyway, so, now, you saw the example of a simple application. Now, what happens if you install Argo? Everybody's using Argo CD or Flux probably here, right? What happens when you install Argo CD? What happens when you install Flux, Prometheus operator, Cloud Native PG, and so on and so forth, right? Nobody uses Kubernetes out of the box. We all install stuff that we need to make it operational. Now, the problem with installing all that stuff is that the number of resources we can create and manage increases drastically, right? Argo, Knative. Knative is actually a good example. I'll get to that later. Crossplane, because my colleagues would not pay my expenses if I didn't mention it. So take a look at this. And this is, bear in mind that this might not look like that, but this is a simple demo cluster. I'm not even having a real production here. Now, if I list all the CRDs, custom resource definitions, you will get a list of all the things that you can manage in this Kubernetes cluster, right? And this is a number of them, right? I don't know how many. VC-shell. 180 resources I can manage through this cluster for one reason or another, whatever that reason is. Now, what that really means is two things. First, my Kubernetes is becoming what it's supposed to be. It's supposed to be a control plane. It's supposed to, Kubernetes was never designed to be a thingy that runs containers and nothing else. Kubernetes was always supposed to be a control plane, extensible API, and all the stuff that you normally do, right? So in my case, my Kubernetes cluster is running containers, it's creating virtual machines, maybe with KubeVirt, it's doing something in AWS, it's doing something else somewhere else, and so on and so forth. And this is absolutely awesome, right? We've been looking for control plane for a long, long time. That's one of the reasons why Kubernetes became so big. Now, the problem with all that is that, first of all, you need to create policies for, in my case, 180 resources, right? Let's say that each resource will have 5 different policies, this field, that's already 180 times 5, 900 policies, right? Still bearable. But the problem comes with the context, right? And to understand the context, you need to understand how Kubernetes API works. You cannot give to the API something like, hey, those are the 5 resources, do something with it. You cannot tell Kubernetes, here is a deployment, here is ingress, and here is service at the same time, right? It's always processed one resource at a time. It's always one resource at a time. And that's problematic. So let's say we do an experiment, right? How would we create a policy that would prevent people from creating more than 5 replicas, like the example I had before? Now you would say, hey, I will create a policy that will say you cannot have more than 5 replicas in a deployment, right? But then somebody else might create HPA, horizontal pod autoscaler. And that horizontal pod autoscaler will change the number of replicas because it's working together with the deployment. And that's a big issue with Kubernetes because it doesn't understand the context of everything you're giving it, but only one resource at a time. So in this example, that's I think very similar to the previous example. Hey, if you have less than 5 replicas, you're fine. But that ignores the fact that there are other types of resources that can change the number of replicas. So the solution that we have for that is to create new resources that we can apply to the cluster one at a time, and then do the processing, do the expansion of those resources inside of a cluster, right? So if I create something like called my application or a database, create my own custom resource definition, and when that is processed inside of Kubernetes cluster, that creates pods and deployments and replica sets and services and virtual services and all that stuff. I have a single resource that is entering my Kubernetes cluster. I can apply the policies, validate whether that's okay, and then expand it inside of the cluster. And we do that with custom resource definition. Now I'm going to show you how that works with Crossplane, mostly because those guys over there are paying me to do that, but you can do it with other tools as well. They're not paying me for that part. So here's an example, right? The previous example, this is the same as the previous example that I showed you, right? I created, I don't know, 7, 8 resources. But in this case, I'm creating a new custom resource definition called appclaim, some parameters. Hey, this is the production namespace, that's the image, that's the port, that's the host. And this accomplishes two different goals, right? The first goal that I'm accomplishing with this is that I can finally give this to somebody who did not spend 75 years with Kubernetes, right? A developer can write this. It's an application. What type of application? Backend application. There is a label over there. What do you need to know? Image, port, and host, or whatever you agreed with that team, right? Which service mesh we are going to use, I don't know, I don't care, right? But you do need to have it, so you cannot avoid having it, but you can avoid exposing it to everybody else in your company. So that solves the problem of how can we simplify things so that others who are not experts in Kubernetes, because let's face it, nobody is, can actually be self-sufficient. They can manage stuff by themselves. But within the context of this conversation, what we are accomplishing is that context, right? Instead of validating each of the 10 resources approximately that will be created separately, one by one, and not understanding how they correlate with each other, we can validate that single entry point abstraction that you made yourself, and then let it pass or no. And we are getting to this picture, more or less, right? This big one that says application that's created by you. You define what is something for your organization. You define what is application. This is application, right? What is a database? That's a database. What are the low-level details, primitives required to run that is something else, right? That's why we create custom resource definitions and controllers. And those controllers are created whatever is necessary at a low level for Kubernetes to operate. Users are happy, Kubernetes is happy, and security guys are freaking out because you can finally apply policies within the context of what you're doing. Now, I'm going to use Crossplane for that, and I'm going to show you one example of how that looks like. By copying and pasting, again, of course. This is a file. I'm going to show you what the file is very quickly, soon. Actually, let me show you right away, right? I applied probably the same what I showed before, maybe similar, right? I created a secret because I was too lazy to install external secrets here. An SQL claim, and this thing will create a database, right? Everybody can understand because there's nothing not to understand. I want a database in AWS. I want it to be Postgres. I want it to be 13.4 and the medium size, whatever medium size means. Developers happy. Me happy. And me happy because I can create policies that will prevent people from doing silly things. They're already, people already are restricted in a ways that you don't need to deal with subnets, VPCs, and all the things required for the database because you have the access to this resource, but still there is room for improvement. So that improvement means creating policies for all this, right? Because what is happening in the background, actually, let me show you what is happening. kubectl get managed. There we go, right? Behind that simple YAML that I showed you, which is my custom definition, this does not come out of the box from anything. I got the internet gateway, main route tables, routes, route to table associations, route tables, security group rules, security groups, subnets, VPCs, objects, database, instance, and subnet group, right? All the things that nobody understands, including me. But it's there, right? And it's being created and it's being executed while I'm talking. You can see that some of them are true, some of them are false. It will be up and running in a second. But from the user perspective, what you really did, you created an interface that I can use, and that's all that is exposed, right? Now, why this matters is that I could never, unless I plan to retire, create policies that will include all the permutations of everything that can happen there, right? So, what I'm going to show you is actually how easy it becomes that now, right? So this is one policy that essentially, let me do it again. There we go. And this policy now says, hey, whenever you create or update something called SQL claim, which is my own resource definition that I defined before, or SQLs, then look for specification parameter size, and if it says small, medium, or large, you're good. If somebody puts anything else over there, you should not let them pass, because it's not good, right? And then I'm going to bind that. This is this one that says, hey, that policy should be applied only and exclusively if you run it in a namespace that has environment variable, environment label set to something that is not silly, whatever that something is. Basically all namespaces. And I have another one that says, hey, this is almost the same as before. If you create or update SQL claim or SQL, but this time I will allow you only medium and large size, no small anymore. And the version number must be 13 or 14, which is still a regular expression over there, right? And this policy will be applied if you ever choose to create a database in production, right? In a namespace that has environment set to production, label set to production, right? Very easy. Two policies, two bindings. One applies to almost anything in a cluster, and another one applies to all the namespaces that are labeled as production. So, what I'm going to do is apply this policy. There we go. Required value, exclusive one validation, spec validation. Okay, what you're witnessing right now is, I don't know. I'm guessing that the specification changed because, by the way, what I'm showing you is alpha, meaning that it is prone to changes. So let me try to figure out quickly what's wrong. If not, you will have to pretend as if it worked. And as if I didn't have alcohol before. Spec validation actions, required value, at least one validation action is required. Failure policy. Fail, it should work. I don't know. Not enough time to debug it. If I would debug in front of you, then you would discover how incompetent I am. I mean, that's a trick you learn in school. What does matter is that if that worked, I could be able to create some databases and would not be able to create other databases. And this would say, you cannot create it. But it didn't work because the spec changed, probably, most likely. Anyways, imagine that it worked. The point is that if it did work, you would see here me not being allowed to create a database because it does not match the specification. And the specification basically said, there we go. You cannot have, oh, let's do this. Let's try this. Doesn't work. It should. Never use alphas. But that gives me 1 extra minute from explanation I was about to show you, and I cannot. What does matter is that validation admission policies will be available when it reaches GA. I think that now it's moving from alpha to beta, and probably half a year from now or a year, depending on how good the project goes. And then, only then you will have it available. I had to enable it specifically in my Kubernetes distribution through a flag. Anyways, they're very embarrassing. I'm going to have some alcohol to go over it later for this favor. Thank you so much. I work for Upbound. We are the company behind Crossplane. I have stuff, and you have 8 minutes for questions.
Cool. Thanks.
Why are you clapping? It failed.
Thanks, Viktor. Well, let's see if your company will pay your expenses, no?
No, I already expensed it before I came here.
Okay.
I know the trick,
professional,
man. Professional, exactly.
We currently have no questions, which either means you explained it really well, or nobody has a clue what you said.
The latter.
Or they all want to go have a drink.
The second and the third combined.
The second and the third is most probably. I'll give it a few seconds, see if we get any questions. I don't think we're going to get any questions.
Yeah, you already gave up. Because I saw the last talk, you were waiting for questions. Because you had faith in the previous speaker, but this time, kind of like, no. It's not going to happen.
I mean, you kind of proved your own point there that
I know. I just kind of hope dies last.
No. If it worked, it would have been cool.
Exactly.
But it didn't work.
It didn't.
So No, but as you can see, Viktor is very friendly, and feel free to come up to him after drinks and talk to him about anything DevOps related or Crossplane. And on that note, drinks.
Thank you.
Thanks.